So here's our agenda for the day. First, we're going to talk about what makes database change management a critical challenge. Next, we'll talk about why database change management is difficult. Then we'll go on and talk about some of the effects of poor database change management. Then we'll move to sort of what you should be looking for in a solution. And finally, we'll talk about how Redgate can help. And we'll actually show you with a quick demo. Perfect. So what makes database change management a critical challenge? Well, this chart shows that IT is under increasing pressure to be more responsive to business demands. It shows here that over half of the business leaders surveyed expect strategic IT services or software products to be delivered from concept to production in fewer than 6 months. More than 80% expect delivery in less than a year. So this pressure has sort of been steadily increasing since the emergence of agile development methodologies a little over a decade ago, and there's no reason to think that it won't continue. So you've got companies like, Google, Amazon, Netflix, as well as mainstays like Microsoft, IBM, HP, really showing us the future of application lifecycle management. So it's lean, it's fast, it's focused on customer experience. It delivers innovation and value to customers as a constant stream, and feedback flows really quickly to drive decisions. So ponderous requirements, design processes are a thing of the past. I'm sure this is something that isn't news to any of you guys who've been in software development for any amount of time. You're probably feeling this. So in order to respond to that pressure, operations and development need to work together. But these two groups have different priorities, which can create friction. So as that pressure for faster delivery increases, so can this friction. And the consequences of that can be pretty painful. So in order to deliver, quickly, reliably, on time, organizations are really striving to find a balance between changing carefully and changing quickly. So database changes are really at the center of these potentially conflicting priorities because they straddle the two groups, development and operations. So developers typically design and author schema changes based on the needs of the business, while DBAs are on the hook for providing a secure, high-performing data platform and protecting the integrity of the company's data. Developers tend to struggle with databases because they're just fundamentally different from code. So for example, in C#, if you added a field to a class and then a week later someone else changed the type, and then a month later someone else changed the name, it usually doesn't matter too much when or in what order those changes happened. All that matters is that the current state of the code builds together and everything works. However, if you were to do the same thing to a new field in a table, it definitely makes a difference because there are data implications at every step of the way. So that alone scares a lot of developers away from maintaining the database. A lot of it's cultural as well. So developers are used to having the option to wipe the slate clean if they don't like something. For example, if they get somebody else's code, whereas DBAs are sort of used to being stuck with the original version and the challenges that come along with preserving that legacy data, keeping it alive, making it work. We've seen some organizations attempt to mitigate this by funneling all database changes through a person or a group of people, maybe DBAs, who are more comfortable with databases, but that's not usually ideal. It tends to create a bottleneck and kind of puts a single point of failure into the process. So typically when we talk to developers, DBAs, IT managers about these things, we get a lot of people nodding their heads saying, yeah, I've been there. I understand that. There's also a ton of blog posts, a bunch of literature out there on this topic. So it seems to be a relatively common and well understood issue. But here's what we find interesting. IT is raced to adopt new technologies and methodologies to respond to this increasing pressure to deliver faster. So they've invested heavily in tools and strategic underpinnings, so things like, agile development, distributed version control systems, automation at all stages of the process, so testing, deployment, all those types of things. So really cool technologies out there people are using. But even with those innovations, many teams are still scrambling to deal with, fragile releases and data loss because little has been done to improve the way database changes are handled. So I was at a conference recently that was all about continuous delivery. It was full of employees from companies who were doing some really cool cutting-edge things to manage their code. But I was amazed at how many people I talked to who would tell me, about all those cool things they were doing. Then I'd ask, well, what do you do about your database changes? And I'd get answers like, well, we just email them to the DBA and he takes care of it. So there's this big mismatch between, most teams' ability to handle and manage their code and their ability to manage the database changes. In fact, we surveyed over 700 development teams recently and found that more than 50% have yet to achieve the most basic characteristic of database change management process maturity, which we'd call, database version control. Something that doesn't show up in this chart, but that we know from experience, is that a lot of people who say yes are still experiencing pain, and they're not getting all the benefits that you might think they are because they're doing it manually. And many times they just don't know a better way because there aren't a lot of great tools out there to help with this. So what does that all mean? Well, when it comes to delivering high-quality software on time, the chain is, only as strong as its weakest link. And for many teams, there are huge opportunities to increase visibility, increase control, while reducing risk and reducing cost by properly addressing database change management in a similar way to what they may have already done with their code. So why is database change management difficult? Why do so many people struggle with it? Why does that sort of mismatch exist? Well, to set the stage for that, let's look at a real simplified explanation of the standard database development cycle. So it has 3 core stages: dev, test, deploy, and basically developers or somebody's modifying the development database. At some point, change scripts are created to move those changes into a test environment. If everything checks out, more change scripts will be created to move it into production or deploy it to production. So in some sense, it's similar to the process for managing and releasing code, only it typically involves a lot more manual scripting and change management overhead. So, for example, it becomes real important to preserve data every step of the way. Branching and merging is typically a lot harder, those sorts of things. With any software project, changes are going to introduce bugs and regressions no matter what. So the more complex the development effort, the more likely it is to happen, and the more likely it is that those changes, those bugs, will have unforeseen consequences. So generally speaking, you can mitigate against that by knowing who changed what, when, and why, knowing what's ready to be deployed, what's not ready to be deployed, knowing what's already been deployed, what hasn't been deployed, by finding issues early and sort of fixing them before they affect the rest of the team or your users, by giving developers the ability to explore breaking changes without hurting others, and by making it easy to roll back when things do break. So source control will be the fundamental building block of the solution to this problem, typically adopted in application code, because it either gives you all of those things directly or makes them possible. Beyond that, things like automated testing, continuous integration, automated deployments can also help. So the benefits of source control are pretty well understood, and most people wouldn't dream of doing a project without source control for their code. But why is it so hard to do the same thing for your database changes? Well, the main reason is, as we discussed earlier, databases are fundamentally different from code. So in application development, source code is really just a file, right? I mean, and the files are kept in source control by simply keeping a revision of each file, labeling it. However, with database development, you're typically working directly with the database at the start. So, like as opposed to script files, meaning you're making DML and DDL queries directly against the current state of a database to modify it, so there aren't really any files being changed. Therefore, there's not, source code or source files to source control like there are with application code. Most existing methods for source control in databases are workarounds. So we mentioned earlier that many of the 41% of the teams who say they're source controlling their databases are still experiencing pain. It's usually because they're doing it manually using one of these workaround methods. So one common workaround is to create source code artificially by scripting out database objects, requiring people to start with scripts rather than start with querying the database. So it's better than nothing, but it requires a lot of discipline, and it's very prone to error. So not only do people have to remember to do it every time, they've got to remember to do it in the correct order. It's very easy to mess that up. It's also something that developers don't like to do, so they tend not to do things they don't like to do, which means that instead of getting a nice comprehensive history, you might get a chunkier history because the developer says, oh, well, I don't want to stop what I'm doing and take the 10 minutes it takes to do this, so I'll do it later. Another workaround that we've seen is to simply check migration or upgrade scripts into a directory in source control. However, these don't really represent a practical history of incremental changes. So for example, it doesn't really allow me to see how a given object, a given table or stored procedure has changed over time. I've got to kind of parse through all these upgrade scripts and find where a given object is changing to figure that out. It can also complicate future deployments. So it's not easy to reproduce any given build of the database when you're using this method. You sort of got to run some baseline create script and then a series of alter or upgrade scripts in order to get to where you want to be. Other examples we've seen are people using, literally just using email and calling that source control, or help desk tickets and calling that source control. But, as you can probably imagine, those aren't very, comprehensive or foolproof methods. So those people tend to still be experiencing some pain. So the bottom line is that if you have one of these white line around the tree or Coke can on the exhaust solutions, your database release process is probably more vulnerable than it should be to errors and probably has non-value add work that you could eliminate. So I wanted to take a moment now to talk about some of the effects of poor database change management. So let's talk about how database change management could silently kill your software quality. And let's take a fictitious example to do that. So don't worry about understanding this diagram or parsing through it. It's just supposed to represent a complicated, branching, merging, release process. But let's imagine that it represents a team's work. So this internal ID department has a team of developers that are working away on some enterprise software. One developer named Jimmy checks his code changes into version control, where they are automatically held at the gates until they're code reviewed by a senior developer, and then finally checked into the team's current release branch. Meanwhile, the continuous integration server will download, compile, package, and unit test the code to make sure that Jimmy hasn't broken anything and that nobody else's changes broke Jimmy. the packaged code is then going to be migrated through an integration environment, QA environment, UAT environment, and staging environment on its way to production. All the while, as the changes are validated from one environment to another, version numbers are automatically assigned to allow anyone to trace back the exact revision for a given build. In the end, you have a whole lot of people paying a whole lot of attention to managing the source code. But here's the catch. Let's imagine that Jimmy's on one of the teams who, say they're source controlling their databases, but don't have a foolproof method. They're relying on developers to sort of manually check things into a directory in source control. Since they don't really build a database from the source files, that directory is going to be ignored by the continuous integration server. That's going to break the unit tests that are pointing to the integration server, so Jimmy then needs to run those scripts manually in the integration environment. While he's doing that, though, he sees that there were other database scripts checked in recently to the same directory, but he has no way to know, which scripts have already been applied to the integration server and which ones haven't. He considers applying those scripts as well, just to make sure that the integration server is fully up to date. But then he realizes that, he doesn't know which ones have been run, which ones haven't, and he can't figure it out without manually comparing the schema against the scripts. And that this would make him the de facto owner for any issues that arise because of that. So with his own tasks and deadlines to worry about, Jimmy doesn't have the time or the patience for that, so he just deploys his scripts, forgets about the others, and hopes for the best. This is something that can silently kill software quality. So a motivated developer just thought about making things a little better, but the process was so frustratingly inadequate that it was impractical for him to do so. So software companies, IT organizations really depend on their developers taking the initiative to improve things, and when they're discouraged from doing so, either by person or by process, the company can easily slowly slide backwards into mediocrity and drag really every developer's morale with them. So anyhow, during the next deployment to QA, somebody's going to have to remember that these specific changes need to get deployed. Since there's no defined strategy for tying database changes to code changes, every time code is deployed, there's a little bit of confusion around exactly, which database changes need to be released, which changes were already released, as well as the order that the scripts need to be run in. One of the longer-term impacts of that is that Jimmy will look for ways to accomplish what he's trying to do without making database changes because it's too much trouble. So if he does need to change the database, maybe he'll just try to do it by changing store procedures, because changing table schemas are even worse. In the end, he's not really trying to find the appropriate solution to the problem. Instead, he's kind of backed into a situation of finding a good enough solution that minimizes his hassle regardless of the downstream impacts. Further complicating the issue, you've got some developers and DBAs who will make one-off changes in QA or productions, things like hot fixes, without going through source control. So or maybe they just don't believe the databases should be under source control. We've actually seen that attitude from some DBAs because they just can't stand the idea of being forced to use a source control system managed by some other developers just so that they can make changes to their own database. So ultimately, this is supposed to illustrate, I guess, that it's pretty easy for every environment to become a perverted branch of the one true database, and then trying to identify why a test works in one environment and fails in another can become a nightmare. Other effects that we've seen our customers deal with who have poor database change management processes, the state of the database is often unknown and there's no history of changes. So when they need to roll back, they maybe don't know what state the database was in before. They're also not 100% sure all the time that what they're testing accurately represents production. They will find that objects are missing or are added into deployment scripts when they shouldn't be, and it's hard to figure out why. Database releases are unpredictable, hard to repeat. Really that comes down to the process being manual and oftentimes poorly documented. It's unlikely that people have to perform 10 manual steps if they're going to do that in the same way every single time. There's oftentimes no backing out. So once you get into a release, database release, and something goes wrong, you've just got to keep going forward. And if something does go wrong, it can leave the team in crisis mode. That presents pretty big risk for downtime. It's painful, so it's not uncommon for teams to have to go through long, complicated merge processes with sort of multiple people working on it at the same time. Something that people try to avoid, which has the effect of causing changes to bottle up, which has the effect of making each release a bit worse. You get into this kind of vicious cycle. Ultimately, every release feels like a kind of stressful, risky, heroic effort. And when you're aiming for efficiency and effectiveness for fast, reliable releases, that's the opposite of what you want. So what if database deployments were easy? Think about your own process. How much time, how many errors could you save or prevent if you could eliminate most of the manual work associated with managing your database changes? And what does that all add up to? Does that add up to an extra sprint a year, extra 2 sprints a year? How much risk could you eliminate? So we recently worked with a team in a Fortune 100 financial institution who found that 90% of the risks of errors in their production system came from the database change management process. And they figured out that once they had a way to manage it properly, they eliminated almost all of that risk. It's a huge win for them. So on that note, let's talk a little bit about what a solution should offer. The first thing is easy, comprehensive database version control. Remember, that's the sort of the fundamental building block of a proper solution. It means, easy in this case means that it should be quick and intuitive for both developers and DBAs to use, because otherwise people just won't use it. You'll be in that situation where people are delaying checking in their changes because it's a pain. It should be comprehensive, so that means that it gets you all the benefits. You can see, when changes have been made, by who, why. You can see when changes haven't been checked in. You can see a full sort of object-level history of how things have changed. If you're working with sandboxes, so like local sandbox development instances, you should be able to share changes easily. And because we're talking about databases, things like dependencies, referential integrity, data loss warnings should all be managed or taken care of. A solution should eliminate manual change script writing and maintenance, or as much of it as possible. So this is an interesting thing that we see. Many of you guys might be familiar with SQL Compare. It's Redgate schema comparison tool. There are other companies out there who make these tools. These tools are pretty much unarguably the fastest, most accurate way to generate change scripts, and most DBAs have one lying around or use one at some point. The problem is that they only work for deployments or database change management if you've got a stable change management process. So for example, it's easy to run a diff between dev and QA and get the Delta script, but what if something has changed in dev unbeknownst to me, or in QA unbeknownst to me? All of a sudden, the tool's still doing what it's supposed to, but it's giving me the wrong result because my process is broken. So we see that a lot. Many times, even though these tools are available to DBAs and save them tons of time, they don't trust them because of the broken process, and they still end up manually compiling or writing change scripts, which obviously has huge chance for error. It should allow you to generate deployment scripts from source control. So this is key to solving the sort of underlying process issue as well as the manual script writing and maintenance issue. When you deploy from source control and source control only, you're ensuring that the code that's been tested and checked in is exactly what gets deployed every time. When you do that automatically using a tool, you eliminate those manual steps and room for inadvertent errors. You also save a ton of time. This is also real critical for automating database builds. So not all teams are at this stage yet where they're doing build automation or practicing continuous integration. But given the trend towards faster releases, agile, and automation, it's likely that most people will need to be here someday. So quick rollback script generation. If something does go wrong, you want to be able to roll back quickly. Backup and restore usually isn't going to cut it. It just takes too long. And you need a way to get back to a known stable version, which should be in source control. Integration with the existing change management infrastructure is another thing that a solution should offer. So you've already probably invested in the source control system. You're using it to manage your application code. Perhaps you've invested in a continuous integration server or a release management tool. If you want to bring your database change management process in line with what you're doing for the code, you don't want to have to go out and invest in a whole new bolt-on change management infrastructure to do that. You want it to plug into what you've already got. And finally, we alluded to this earlier, but the ability to extend to automated testing, builds, and deployments. Might not be here yet, but if the case is that you have to be here someday, the business asks you to be here someday, you don't want to have to throw away your database change management solution and go back to the drawing board. You want to be in a position where you've got something that you can plug into that. So how can Redgate help with this problem? So this is a diagram. I apologize, it might be a little bit hard to read, but in the center you sort of got a representation of the typical database delivery lifecycle. So starting on the left here with a developer, checking changes in the source control, and then maybe building and testing those changes and reporting the results back. Then finally on to deploying scripts, and monitoring and alerting for your production server, and getting schema change alerts for when those hot fixes or when those things do happen that get ultimately put back through source control and run through the whole process. The icons on the outside here represent Redgate tools that can help with each part of this process. So up here in the top left, we've got a product that makes it easy for developers to get their changes into source control. We've also got products that make it easy for DBAs to get their changes out of source control. So that right there fills two critical gaps for most teams. For teams practicing continuous integration or continuous delivery, our software plugs into your CI server. You can automate database unit testing, builds. You can also plug in the release management tool to sort of deploy those packages onto other environments. The result is faster, more reliable database releases with less time and effort required from you. Currently, our technology is used by 91% of the Fortune 100. We view UX as a competitive advantage, and our guiding principle, you may have seen it on the welcome slide, is ingeniously simple. So as a result, the products are easy and intuitive. This reduces ramp-up time and adoption overhead. We also plug into the existing development and change management infrastructure, so there's no need to bolt on and learn an entire new framework. Whatever you're using, Git, Team Foundation Server, Subversion, we plug into that. Whatever you're using in terms of continuous integration, we plug into that. And it's pretty easy to get up and running. So most clients are typically up and running in less than a month. A recent success story from one of our clients, this company is called Practice Fusion. They're an electronic health records company with over 100,000 customers. They were in a position where they were growing very quickly and struggling to scale because of their manual error-prone database deployments. They ended up using Redgate to automate database versioning, eliminate handcrafted alter scripts, and really bring database change management in line with what they were already doing for their application change management. The results were about $25,000 per year in productivity gains alone, simply by automating manual tasks. I believe the development team was around 10 people too. They now have 100% confidence that what's tested is what ends up getting deployed, and holes in their process are surfaced by automatic validation. So if something sneaks in, a change sneaks in, they find out about it quickly. They don't have to worry about it. Finally, they went from discovering Redgate tools to using them in production in less than 2 months. So at this point, I'm going to turn it over to Arneh, who will give us a quick product demo.
Thank you, Max. Hello, everyone. My name is Arneh Eskandari, and as Max mentioned, I will be quickly walking you guys through a demo of our tools and show you how we can help you improve your SQL Server database change management and also make your releases more reliable as a result. So hopefully everyone can see my screen okay. So obviously a key piece to an easy change management is a source control system. So we all know that this is pretty straightforward when you're working on an application code, but when it comes to databases, it is not as straightforward, simply because there is no easy plugin to Management Studio. So, and therefore what we've done is that we've come up with this tool called SQL Source Control, which is basically a plugin to Management Studio, and it enables you to create a bridge between your databases in SQL Server and your existing source control systems such as TFS or Subversion or any other source control systems that you might be using. So for the purpose of this demo, I'm going to work on my VentureWorks database. So the first thing that I need to do is to link this database to source control. So here is the plugin for SQL Source Control, as you can see here. So you can go here and easily link your database to source control. So I can click on this link here. As you can see, we have out-of-box support for these source control systems. And for the purpose of this demo, I will be using Subversion. So I already have a folder created in Subversion here. So I'll be using this AW webinar folder here. So I'm just going to copy that. And I'm going to paste the URL here. Okay, now with SQL Source Control, we support two database development models. So one is dedicated database when where each developer has their own copy of the database, and we also support shared where everyone's working on a shared SQL Server database. So for this demo, I'm just going to be using the dedicated model, but I'll quickly point out what the main difference between the two is. So I'm going to go ahead and link my database. So as you can see here, as soon as you link your database icon turns green, which easily shows you which databases you have linked to source control. And we also have this blue blob here, which is telling me that I have uncommitted changes to source control. So when I go to the Commit Changes tab, here you can see that it presents me with the list of objects that I have in database that are not committed into source control yet. So you can simply go through each object, and at the bottom you can see the difference in the script between your actual database and what you have in source control. Obviously, our source control repository is currently empty, so we're going to basically do our baseline commit at this point. Now, before I do that, I'd also like to point out that with our source control solution, you can also version control your data changes. So if you have lookup tables or reference tables that you make changes to on a regular basis, it's a good idea to also put those under version control as well. So you can easily do that using our SQL source control tool. So what I can do here is just right-click on my database, go to other SQL source control tasks, and click on link or unlink static data. So here I'm going to pick my lookup table. So I have a couple that I want to version control, so address type and contact type, and save and close. So here you can see that now I have two data links as well as the schema objects that I'm going to commit into source control. So I'm just going to go ahead and write a comment here. Commit this into source control. And you can see that the blue blob is no longer there. So if I go to my source control repository real quick, you should see that now I have a SQL file for each object in source control. So under tables, I have a SQL file which is basically create script for each of my objects. Now, basically what this does is that it creates a working basic copy of your database for each revision. So every time you commit a change into source control, that will be basically a full copy of your database with the latest changes, so you can easily take that version from source control and deploy it to another environment or database if you want to. So I'll show you guys how that's done later in the demo. So now that we have our database under source control, we can easily go ahead and start making changes to it. So I'd like to make a couple of changes to my database here, and then I will walk you through how you can use our tools to deploy those changes to a target environment. So let's go ahead and let's say create a new store procedure here. So here I'm using one of our productivity tools called SQL Prompt, which is basically like ReSharper that you use in Visual Studio. So it makes it really easy for you to write scripts and quicker and more efficiently. So I can execute that. And I'd also like to make a quick data change as well. So okay, so now I've made a couple of changes. As you can see here, the blue blob has appeared again. And the cool thing with SQL Source Control is that it easily shows you where those objects that have been changed are. And this is really cool, actually, especially when you're in the shared environment where everyone's working on the same database. So this blue blobs will start appearing as soon as other developers start making changes to them, or you start making changes to them as well. So you can easily see what objects are changed and so on. So here I've made a couple of changes, so I just want to go ahead and commit those into source control. Now you can also commit them into source control by just right-clicking on your database. Okay, so here you can see that I have I've made a change to a data. So here you can see the difference. So this is what I have in source control. We're adding a new row to our contact type table. So it's basically going to copy this across to our source control. And here we have a new store procedure that doesn't exist in source control. So I'm just going to, again, write a comment here. Excellent. So now I just realized that I did, when I created my store procedure, I did a select start from, which is not a good practice, so I just quickly want to go back and make a change to that. So I'm just going to go ahead and modify this real quick. So again, I'm going to use SQL prompt, which makes it really easy for you to see what columns you have inside your table and easily pick the column names that you want to. Okay, so I'm just going to go ahead and commit this into source control. Okay, so here you can see again, it shows you the difference between what you have in source control and the latest version on your database. So I'm just going to say replaced start with column names and commit that into source control. So another really important feature is the audit trade-off changes. So being able to see the history of the changes through your source control solution. So we can easily do that by right-clicking on our database, and if you go to View History, here it will basically show you all the different revisions that you've committed into source control. So as you can see here, this is our initial commit, where we committed all our objects as well as the data links. Here's the second commit, where I created a new SERP procedure and added a new contact type to my contact type table. And you can easily browse through the objects, see the differences going from the previous revision to the current revision, and you could do the same for the latest revision. Okay, so as you can see, it's really easy and straightforward to use our tool and start version controlling your database changes through Management Studio. But another really cool feature is that we can also, we've also integrated our comparison tools to enable you to easily deploy your changes from a specific version of source control to a target environment. Now, you can use this functionality for three main processes. So one is obviously for deployment. So if you want to pick a specific change, push it up to a target environment. You can also use the same feature for rollback. So let's say that we just, I just committed something into source control, made a change to my database. Now I want to roll that back. So I want to go to the previous version of my, from my source control. So you can easily do that. You can pick the version that you want to roll back to and use SQL compare to roll back your database. And finally, the third feature with, that you can use is using the same option to compare a specific version from source control to another version. So for instance, if you want to see what changes have been made from your initial commit going to your latest version, you can easily compare those, again, using SQL Compare Pro. So for the purpose of this demo, I want to go ahead and push my latest version from source control to another environment. So I want to push it off to my, let's say, my AW prod database. So I'm going to pick the version that I want to deploy and click on SQL Compare Pro. So here, so this is our SQL Compare tool. Some of you might already be familiar with this. So it's basically enables you to compare two different databases or script folders to databases, and it will basically generate the update script for you, and it also enables you to deploy to your target database using the tool. So here I'm basically comparing my version revision 15 from source control to my AW production database. So I'm going to go ahead and compare. So here it's telling me that there is one object that exists only in my source, which is my development database, which is that USB get contact store procedure. So here you can easily pick which changes you want to push off to your target environment from source control. And once you've selected them, you can go to Deployment Wizard. You can either generate the deployment script, or you can just use the tool to deploy directly. So here it generates our deployment script, so you can review it. You can also save it. And if you're happy with that, you could go ahead and deploy. So now if I go back to my AW database here, you can see that my USB get contact store procedure is now moved to the other database. Now, you could also do the same thing. You could automate this process. So if you remember, one of the main features that a solution should have is automated testings and builds for deployment. So you could easily use our SQL automation pack to set that up with an existing build system. So for this demo, I already have a build process set up with Jenkins, so I can quickly show you that. So if I go to my Jenkins here, I already have a project set up, which basically uses our SQL automation pack to pick a specific version, the latest version from a source control repository that I've specified, and it will go ahead and build it, and it will update my AdventureWorks CI database to be the same as my development database. So here I've made some changes already. So what I'm going to do is I'm going to go to my build system. I'm going to enable this project so it can start building. And I'm going to go ahead and click on Build Now. And what this is doing is basically, the first thing it does, it tries to build the database from scratch. And then once it's built successfully, then it will go ahead and update my target database, which is the CI database, to be the same as my development. So here it's basically comparing those two. Now it's going to update my CI database to be the same. And once successful, it will basically give me a report that the build was successful. And we'll go ahead and also validate that by just quickly checking our CI database. Okay, so you can see our build succeeded. So if I go back to Management Studio, check my AdventureWorks CI database, go into store procedures, you can see that it also pushed my USB get contact store procedure to this environment using a continuous integration process. So so this basically concludes our demo. So now we're going to open up to questions. So feel free to type your questions in the chat box, and we'll start answering them one at a time.
Thanks, Arne. So this slide shows you how to use the question screen if you don't know how to do it. If you do have any questions, please type them in. We'd be happy to try to answer as many as we can. Okay, so the first question is track permission changes.
So SQL Source Control basically enables you to track any changes that you make to your database objects, which also includes permissions.
The next question was, how does version control or SQL Source Control handle blobs, BLOBs?
Sorry? I'm not.
We're going to look into that one for you. We don't have the answer off the top of our heads right now, but we'll look into that and get back to you. We've got your email address. The next question was, can you demonstrate a rollback of a database? Yeah, we'd be happy to show you that quickly.
Sure. So if I go in here to my database, go to view history. So my database is currently version 15 of source control. So if I want to roll back to revision 14, I'm just going to go ahead and click on SQL Compare Pro. So here I'm comparing the previous version to my actual development database. So I'm going to go ahead and compare. Okay, here is the difference between my latest version and the previous version in source control. So it's going to replace the select first name and last name with select star from. So I'm just going to select that, go to deployment wizard. Okay, so if I go back to my database, it should show me that now I have uncommitted changes because the version of my database changed. So you can see that now my database says select star from, and the latest version of source control is select first name and last name. So I can just go ahead and commit this into source control and then make this my latest version now. I can call this rollback to version 14, but this will create a new revision. So that is going to be the same as my revision 14.
The next question was, can you explain the difference between dedicated and shared environments, or show the difference between dedicated and shared environments?
Sure. So there's only one difference between the two, and that is this get latest option here. So when you're in a dedicated model, obviously each developer is working on their own copy. So in order to get the changes from the other developers that are committed into source control, they need to go to this get latest tab to see what other changes have been committed by other developers. But when you're in the shared model, obviously everyone's just working on the latest version all the time, so you don't really need to do get latest. So the only option that you use in a shared model would be committing changes, as you're always you can always see the latest changes being made to the database by other people as well. So, and also another main feature with the tool is that when you go to the commit changes in the shared tab, you can see the changes made by all developers, but only the changes that are made by yourself are selected by default. But you also have the option to go in and select the changes made by other developers and commit them into source control as well.
Okay, thanks, Arneh. Those are all the questions we have in the chat pane right now, and we're almost out of time. So here are a few suggested next steps for you guys. If you're interested in learning more about this topic in general, we've got an excellent selection of articles at this URL. I'm going to go ahead and we'll go ahead and send this in the follow-up email. I'll give you a minute to copy it down. But there's some good stuff on there, tons of articles about database delivery patterns and practices, all different levels too, from very basic to very advanced, continuous integration, continuous delivery, etc. We'd also be happy to arrange a consultation with you, give you a chance to tell us about your situation. If you've got more in-depth technical questions and want to see a personalized demo, we'd be happy to show you that. Really figure out if Redgate might be a fit for your organization quickly. Finally, if you have any follow-up questions or want to set up a consultation, you can go ahead and email me directly. My email is right here, max.anderson@red-gate.com. Or if you just want to type, please contact me into the questions pane. We could reach out to you. So perfect. That will conclude our demo for the day. thank you guys again for your time, and let us know if we can do anything else to help.